Hello, everyone, and welcome to another course on equipping ourselves with data-related skills. In this course, we are going to be going through data engineering with Python and Postgres. My name is Valentine, and I'll be your facilitator. So we are going to follow this structure, starting to learn about the objectives of the session. After that, we'll talk about important concepts when it comes to creating deliverables in relation to data engineering with Python and Postgres. And we'll talk about why we would want to learn about them, and also why organizations value professionals who have the ability to work with these technologies. Then after that, we'll get into a practice session where we'll apply concepts in relation to the topic at hand. And towards the very end, we'll just talk about the next steps. So let's get started. By the end of today, we are expected to have achieved these learning outcomes. We should be able to explain generally core data engineering concepts and workflows in relation to the tools that we are going to be working with. That's Python and Postgres. We should also be able to create or design pipelines using Python and Postgres. The idea is that in that process, we will create databases, tables that will eventually hold the data that we would want to hold. Then we'll also implement ETL, that's extract, transform, and loading processes. This is a design approach that data engineers or data professionals that work with these two technologies use. So the idea is to implement ETL, that design approach, when it comes to our work, and that would just involve working with data. So those are the four learning outcomes that we should have achieved by the end of today. So starting off, we've done a past workshop on data engineering specifically with Python. Well, we did not really branch off into specific technologies. But generally, just to recap something that we talked about, which is data engineering, what it entails. It just involves building and maintaining systems for collecting, processing, as well as analyzing large sets of data, and then loading that data somewhere that other stakeholders can get to interact with the clean or transformed data. We can create what are called pipelines. Pipelines would collect data from different sources, whether it's different relational databases. Our focus for today would be, assuming that we had a Postgres database, how can we be able to create a pipeline that collects data from that Postgres database, transforms it, then afterwards loads it somewhere in a destination Postgres database that can be used by other data stakeholders, such as data analysts or data scientists. So we'll perform data engineering in this session by creating a data pipeline that allows us to be able to collect data from a Postgres database, transform that data using Python, then again store that data in a Postgres database. The reason why, of course, we would use Python is because it is quite popular still when it comes to data processing, data analysis. There are a large number of libraries as well as frameworks which have been tested, and they've been used by other data professionals to also create data pipelines for the research problems that they've been facing within the organizations. So there are quite a large number of libraries, starting from Pandas, which is a standard for data analysis work when it comes to Python. There's also Dask, which is also a library just like Pandas, but now for large-scale processing. There's also PySpark, which integrates with Apache Spark behind the scenes to be able to use what is called distributed computing or parallel computing. So you are able to leverage the ability to perform multiple tasks at once, and you just reduce the amount of time that you would take when it comes to data pre-processing. So those are just a few tools that might come in handy. So Python actually can think of it as the bread and butter of data pipelines. Then again, Postgres would be where data would be stored. Many organizations use Postgres for the reason of, it's a relational database system, which means data can be stored in a tabular format that's understood by many stakeholders. In addition to that, you are able to perform SQL queries, advanced SQL queries. You can perform some advanced concepts such as indexing, which is important for querying data, for being able to retrieve data from those databases, Postgres databases that organization might store data in. And also when it comes to extending the capability of Postgres, the database itself, there's support for that, and also the support for being able to scale that database as opposed to other relational databases. So the two tools that we are going to learn is just how to work with Python as well as Postgres, just for being able to create data pipelines. The idea is that by the end of it all, you should be in a position to say that you're in a good position. But just to talk a bit more about these two types of tools, when it comes to handling data, there are a few deliverables that we might end up working on, or the kinds of work that we might end up doing when we work with these two tools might be, which of course would be our focus for today, creating what are called ETL pipelines, which is extract, transform, and load pipelines. So you could create a pipeline which has different components. You can think of it as, you can even just think of it as functions. Function that extracts data from different sources, then it passes the data to another function called transform, and then that function performs transformation techniques. Then it passes the data, the transform data, to a loading function that stores the data in some destination source or data source. It could be, now in our case, data Postgres databases, or just one Postgres database. So ETL pipelines would be one of those things that you could end up creating as a result of having knowledge of Python as well as Postgres. Being able to also perform data analysis and reporting. You could query data from Postgres and import that data, explore it, and handle, perform pre-processing techniques, and as a result, decide again to perform data analysis techniques and generate reports which would have visualizations or tables. You could also end up performing automations, tasks, or scheduling tasks, still using Python and Postgres. Maybe you might want to execute some sort of task against your database, or you could also decide to collect data from a particular Postgres database after every maybe few hours. Then again, these two tools will come in handy. Data cleaning and transformation, you might end up doing that kind of work that generally allows you to prepare data for further analysis, whether it's for your own analysis or for other stakeholders' analysis. But this component of data cleaning and transformation is part of the ETL process, which happens under the transform component or stage. So a good example of a pipeline, a very basic example of a Python pipeline, a Python and Postgres data pipeline, would look like this. So this would be just code example, where you might want to use Python as well as Postgres. So initially at the very top, we import pandas as well as Alchemy, SQL Alchemy. This allows us to be able to interact with the database itself, the relational database that we would be working with. Postgres is one of the many databases that are called relational databases, and those databases usually use a language called SQL. So in order to store data in those databases, one of them being Postgres, you need to be able to write what is called an SQL query. Our focus will be being able to perform just various tasks. We'll give a few examples, SQL code examples, but we won't focus so much on how you write SQL code, that is something for another session. Our focus would be to use the tools that would allow us to be able to interact with Postgres as well as Python. Pandas for data manipulation, and SQL alchemy to be able to connect to databases and relational databases, and one of them being Postgres. We'll also introduce another library called Psycop G2 library. It's a pandas. It's not a pandas. It's a Python library that allows us to interact directly with the Postgres database. It's one of those types of databases that gives you an extensive ability to interact still with the Postgres database, but now you tend to write a whole lot more of SQL code when you go that route. But we'll introduce maybe a few examples, just a few examples, so that you are familiar on how to work with that library. But our main focus will be the tool for creation of data pipelines. So assuming, like, in our first case, we import those libraries. Then after that, we extract maybe data from a data source. In our case, we have a CSV file. Then we transform the data using that line that you see here. We create just a new column, which is as a result of the existing column. Then after that, we just load the new data frame that contains already the transformed data into a Postgres database. And you can see we are using the create engine function from SQL alchemy to define the configuration information for the Postgres database that we want to connect to. We provide the name of or the type of database, relational database, SQL database, that's Postgres SQL. Then we give a username and a password, and also localhost would actually represent the host. It could be a particular IP address that you replace that, and also the port number 5432 / now the database name itself. So that is how you connect to a database. And once you have used create engine, you actually create an engine that you can be able to use to be able to perform now queries to that particular database or against that particular database. So that's just a quick overview of what would be expected. How would organization benefit from use of this tool? So these two tools, one of the things that they would end up getting are efficient ETL processes, being able to have data pipelines that are robust. So using tools like Pandas, Dask, SQL alchemy from Python allows for the efficient extraction, transformation, and loading of data from those various data sources into Postgres databases, as opposed to using other maybe commercial tools that might not be well tested or do not necessarily have extensive support from the builders of the tool or from the community. Sometimes you would want to use a tool that is mature enough, and those two particular tools are important, and they've gotten to that point. Scalability and flexibility. One of the bragging things about using Postgres is that, when you use Postgres, you're able to scale your database as opposed to if you were to work with databases such as MySQL. So when again you use Postgres and Python, you're able to have that ability to grow your data as the organization grows, as the data types that are being collected also grow. Open source solutions, both Python as well as Postgres are open source, which means that you are able as an organization to reduce software licensing costs, and the only thing that probably you'd end up paying for would be just storage costs when it comes to hosting those applications or your data pipelines, or even just the databases on the web. You just need some hosting. You do not necessarily need to pay for the software. You don't actually need to pay for the software. It's available, anyone can use, and there's a whole lot, there's a big community around its development and making it available for everyone. You're also able to perform complex queries as well as perform analysis. Postgres provides advanced SQL capabilities, so you're able to write complex SQL queries. And when you use it with Python, which is a standard for when you use it with Python's pandas, which is a standard for data science or data analysis, then you are able to do a whole lot more. And you also have room even for being able to work on applications that use machine learning concepts and also future technologies or emerging technologies. Yeah, so those are just a few reasons why you'd want to look towards using, or organizations, would highly encourage or would be using these particular two tools. The tools, specific tools in relation to Python as well as Postgres that we are going to be working with are the mentioned tools. We've categorized them in different buckets. There is data extraction and collection. So you have Scrappy, Beautiful Soup, Request, and Selenium, which we can use to extract data from various web sources. Transforming and cleaning data would involve the use of Python, Python's pandas, Dask, NumPy, as well as PySpark. Database interaction. So there's Psycop G2, the one that I had mentioned earlier. There's SQL Alchemy, which we have already seen in a code example, and also another tool called Pandas SQL. Data loading. There's SQL Alchemy. We can also use that. We can also use Psycop G2 for also loading data into a database. And there's also PG bulk load, which allows us to be able to load lots of data at once. Workflow automation and scheduling. So once we've created data pipelines, which we would store in just Python files, we can now use tools like Apache Airflow or Luigi to be able to schedule those pipelines, maybe in whatever manner that we would want, and manage them in the sense that we would want maybe to I don't know, maybe schedule them in a certain way or update the code. And Apache Airflow also provides, instead of connecting the way we would connect using, say, SQL Alchemy, Apache Airflow as well as Luigi, they have sort of plugins which they're called connectors, which are for different data sources. So instead of thinking about how to connect maybe to a particular data source securely, then these workflow automation tools just help you to be able to achieve that. They're also open source tools. Hopefully we'll be able to cover such tools in the near future. Depends on also the reception of these workshops. Monitoring and logging, to be able to monitor how your pipelines are performing, whether they are failing, whether they are, how much resources they're consuming. There are tools such as Prometheus and Grafana, which also allow you to just be able to log any errors that you might get or the pipelines might get. Maybe the specific data that has sort of gotten into the pipeline and it has resulted into some sort of error. Then those tools should be able to help you get to that particular case. All right, so that's it with regards to just a quick overview from a theoretical perspective. We're now going to go into the practice work. So click the link in the description. It should take you to a page where you can click on the sample practice resource, which should take you to this page. So this sample resource doesn't have challenges, but if you want, you could always become an after-work member. But it should help us be able to go through just the concepts that we've talked about. So starting off, we are going to go through prerequisites. Prerequisites will involve being able to set up some sort of database somewhere that we are later going to extract data from. So the prerequisite section that you see will just involve connecting to a database, actually creating a database, an online database, connecting to it, then creating a database inside, creating. So this is how it works. When you're working with databases, so you tend to work with instances. So for Postgres, we are going to create a Postgres instance, which is just an application. So we are going to deploy an application, a Postgres application, then which is a database application. Then inside the application you have, and I'm going to be using the word instance instead of the word application. Inside the instance, you're going to have databases. So initially, we are going to create a Postgres instance. There's a service that gives us just free instances, so we can create just one for that. And once we have done that, what we are going to do next is to connect to that instance that we've created. And then we are going to create our own database. Then we are going to, inside that database, we're going to create our own tables and then populate those tables with data. Then once we have done that, then we are going to go into the extract, transform, and load steps. So yeah, so that's what we are going to do. Can't wait. So let's get started. The first thing that you do is to save this notebook as a copy. So go to File, then Save a Copy in Drive. So once you have done that, I'll just open mine in playground mode. All right, so once you have done that, the next thing that we need to do is to now go into prerequisites, then start off. So we are going to set up and set up to a connecting to a database that we are going to connect to. There's this service that's called Ivan that provides us with free Postgres databases. So there are many ways you can do this. You can install a Postgres instance locally. You can decide to use an online platform that allows you to create databases. So what we are going to use is one of those platforms. You can also go for, if you really want to make sure that you're deploying something that will be used with an organization. I think the bigger providers of just online web solutions or cloud storages or cloud applications such as AWS, Microsoft Azure, and Google Cloud, and also DigitalOcean. There are quite a large number of them. If you want to create a database for an organization, that is usually the best route. But for us, we're just learning, so you're just using this as a way of learning. So click on that link, and it should take you to this page, and you just click on Start, Get Started for free. You can sign up with any account that you want. And you can pause the video, by the way, if you feel like I'm too fast. So once you have done that, you will get to a dashboard that looks like this. And you won't have the two services that I have here. These ones are just, this is a MySQL database. This is a Postgres database. I'll call it Learning Postgres. You won't have those ones. So you need to create a service. So click on Create Service. Then you choose Postgres. Then you choose the free plan. And then, you create a free service. I can't create one. The reason is because I'm already using a Postgres, one free Postgres service. It's for learning. So, yeah, so I would have to delete the one that I have before I do that. So once you have done that, let me go back to my services. So my organization, okay, my services, actually under services. Once you've gotten to, you'll just follow the prompt to the very end. There's some steps that you'll be asked about setting up a few other things. Just say skip for now, skip. We just want the core of what we're going to be using. So once you've done that, you can be able to see now once you go to services, you'll be able to see your instance. And you can see the cloud provider. Here we have DigitalOcean, could have been AWS or Google Cloud, etc. But yeah, so click on it, or it might take you to this page where you can be able to get now these particular, the mentioned details. These are the ones that we're going to use to connect to our database. So, you can leave that open. And then now let's go back to the notebook. We will use now the mentioned details for connecting to that instance. So going back, and the link, you can find it in the notebook, by the way, if you're wondering. So we'll start off by just quickly learning how to connect to a database, to that database that we have created. Or not that database, that instance, not really connect. I should have said connect to an instance. I don't know why I chose a database, but it's okay. So we're going to import Psycop G2, which is a Python library that allows us to interact with the Postgres database, but we can also use SQL Alchemy. So let's just do this. We'll import that. Then the next thing, we define a function, and this function will allow us to connect to that instance. This function will take a username, password, host, port, and a database name. And those details are what you see here: database name, host, port, username, password. You can just view your password from here. It's actually what you will see there. It's already in the notebook. Yeah, so that's what you're going to see here. And also SSL mode, we've said we've set that to require, because it's also, on require here. All right, so once we have done that, the next thing that we need to do, once we have seen that those are the parameters that we need to have, we are going to connect to our Postgres instance, and we are going to use the connect function from Psycop G2, and we are going to specify for each parameter the values that will be passed to the function, and then we are going to specify that we want to execute now this particular connection once we have done that, once we have run this particular code, we commit it, we run that particular connection, and then we just print out connected to database successfully, and voila. So that's what we are doing here. We're just connecting to the database using the connect function. I just reorganize this code for ease of understanding. And once we have done that, once we have defined our function here, we can then now decide to easily, first of all, just display or assign those details, or assign the details, the configuration details, to just the respective variables, as you can see here. And then we connect to the database. We call the function, and we pass now the variables that we have here as arguments. And the result of that will be now a connection, which will be stored in con. And we're going to use that connection later. So run that. Should take a few seconds. Awesome. Once we have done that, the next thing that we're going to do, we have now connected to that database. The next thing that we're going to do is not the database, this database name, but the instance itself. We've connected to it. We're now going to write another function to create now another database. We have a default database here, but in that instance, but we can now decide to create another database that we can use for just our own tasks. So what we are going to do is create another database. Not even before that, we are going to import SQL. This SQL function will allow us to be able to, it's a class, by the way, not a function. Yeah, so it's a class. So this function, this class will allow us to be able to execute just SQL queries. So for example, what you see highlighted here, it's an SQL query that we are executing, and SQL, the SQL function from SQL is the one that we are using. So we define the database name, the function create database, then we specify the connection, the one that we have gotten here, and the database name. Now this database name will be now the new database that we name, that the new database name that we want to have for the new database. Then we just check if the database exists, assuming that we had another database already that exists, and we want to create a database with the same name. Then this particular line over here, actually what's this logic over here is what will take care of that. So initially we just quickly check whether there's a database name. Using this query, just selects from PG database, which is a database, an inbuilt database within Postgres that lists out, it does list out all the databases within the instance. So we select just, we try to select just one record that has a database name as what we have here. But again, if we don't have that database name inside PG database, then we will be able to run this code over here. So this is a cursor. When we are working with PG Psycop G2 library, we would normally need to start a cursor, which would now perform the queries that we want. And this is what we use here. So here we execute the query that we want. And the same case, and it takes this particular query that we have here. And the same case, the query is actually here, but it takes this input that we have here. Then here, it's the cursor itself, it fetches one of the results, which of course will turn out false if we don't have any records, and if it doesn't exist, then we now execute this other this other statement, create database, then the new database name, etc., and we format now the identifier, that's the new database name, to what would be allowed, and we print out database created successfully. Then if a database already exists, we'll just print out that, and we close the cursor. That's it. So that's another step that you can use. So this might seem a bit more complex. I was saying this is the most tedious way of just working and connecting to a database, but you can bear with me. When we get to SQL Alchemy, things will just feel easy. So now here we have already defined our create database function. So we might want to create our database. I have created one that says create your name DB. You need to change this, by the way. And also, I forgot to mention, you also need to update these connection details. Sorry for that. With your own details. So just copy the connection details and replace them here. Ensure you don't have spaces. They all should also be in quotes. So once you have done that, sometimes you might, if you run this code over here, you'll get database already exists. It might mean that already you're connecting to my own database, but you need to connect to your own. So already I've created this database. It's called your name, but you can change this maybe to what suits you best. Like I'll just save it as Valentine DB, and I'll rerun it again. I might get it, so it already exists. Let me DB3, DB5. Let me just do DB5. Yes, I've created DB5. And now, if I want to connect to the database, I'll use the function that I had already created earlier, this function, to connect to the database. I'll just pass the same information, but I'll change the database name. So, so that's what I'm doing here. I'm just updating the database name. So DB5, I should save it to DB5. And I'll just apply the same details that I had before, and I store the connection in con. Awesome. To create now the tables, so the tables within that database, I'm calling them source because that's our source database that we're going to use in our pipeline. So what we do is now we create another function called create table. We start a cursor, which we create here. We create a cursor, and we execute a query that we give to this function, and the query will be here. This what is enclosed in the triple quotes is what I've highlighted is the query. So this SQL query creates a table, if it doesn't exist, called customers, and it has this column, customer ID, serial, primary. It has a primary key, first name, last name, and email. These are just data types that we would give, like serial, primary key, etc. There's just some more information that we would give that allow for just validation. We'll work on SQL in the future, not now. This is just for ease of learning. So we create customers table query. So that query is stored here. So whenever we pass it to this function, so connection will be this connection. We'll pass it to this particular query. It will be executed. And commit just means actually when you run this code, you need to commit to be able to execute. And then like in our case here, we're going to create that table customers. And we also create another table called orders. So we want to create two tables, and these are the fields in the respective data types. There's a numeric with the mentioned figures. I won't go so much into the specifics, but you could always just have a look and see what's happening. And then we call just the two functions. We call the function create table twice, but again, we are passing different queries so that we create the two tables. Awesome. Once we do that, we then now populate the table. So to populate it, we are still using psycopg2 to create our query. I mean, this is usually tedious, but what we are doing here, we are defining a function. Actually, we are calling pandas so that we are going to use it later to just be able to get data maybe from a CSV file, which we do here. And we want to pass this data from a CSV file into this particular data source so that we can be able to query it when we are working on our data pipeline. So as you can see here, what is happening is that we are, where is it? Sorry. Okay, so what is happening here is that we are inserting data, customers data, which is, we're also going to insert orders data, but for customers data, we are connecting to we're using the connection that we had created earlier, and then specifying the data frame. So the data frame is taken in, and we iterate through the data frame. Before we iterate through the data frame, we specify width, which allows us to be able to perform with block to be able to perform our code efficiently. So we want to what we want to do is to iterate through the data frames rows, and we're just using a for loop, as well as specifying the index as well as the row, the rest of the data, and using a cursor execute function to specify the SQL code that we want to run. So we normally use insert into SQL statement to insert data into that. You don't need to learn so much about this. This would come in handy for loading, but we'll get to learn how to load with SQL Alchemy, which is a whole lot simpler than this. So what we are doing here, we are inserting into our data set, our customers table. These are the columns that we are inserting into: first name, last name, and email, and the values. And we specify the customers table, and we specify the values now. We specify the columns, but here we specify now the respective column names in the DF data frame. And we commit that, and we iterate through the entire data frame. And then once we have done that, we will have we have done our loading, and we print out that statement. So run that. We've done that now, and now we're also going to do the same thing with the orders data. You can always even download this and preview it, or preview it later to just see. And we're also importing this data, or inserting this data into customer ID, order date, and total amount columns. All right. So once we have done that, we're now going to create our pipeline, which will be a whole lot easier. So we're going to start with connecting to a source database. So how we connect to a database is, again, actually the extract component of a data pipeline would, I remember the example I was giving you earlier. I'm trying to look at whether I can be able to showcase the extracts. Okay, so here we had this example that you can see here. The extract component is actually this that we are doing here. And this can be the extract data from a CSV file. It can be as complex as you would want. Like right now, we are going to extract data from a Postgres database. And we are going to now to use SQL Alchemy because it allows us to be able to quickly connect and get the data that we want. So to connect to a database using SQL Alchemy, we import SQL Alchemy and want to work with create engine function. We define our function, connect to database, specify the different parameters that we want, and then the connection, we create a connection string, which is an F string, and it will contain the details that we need to connect for the database. And then we create an engine from this connection string, and then we return that engine. So we'll use that engine to perform queries on our database. So the details that we have here are what we are passing to the function. I can just rename this to db5. And then I call this connect to database, and what we'll get here is the engine we will store in source engine. So I'll run this and I'll also run this. So the F string here, you'll also see it's actually what's provided here. So it's also an easier way of just connecting. And you can use SQL Alchemy. You can use SQL Alchemy with just different databases, SQL databases, not just Python. And yeah, so that's that bit. The next thing, so once we have connected, we now can be able to pull data. So we define our extract function. So the extract function will actually take the connection details that's from engine. So to be whatever that we'll have specified, the source engine. But now we specify that we want to get our data from the engine. And, the engine would, be the database that we have. And we would want to select all records from that. So we specify the SQL code, select from, or select all records from customers, or select all columns from customers table, which we do. And also we also select all columns from orders table. And we specify the engine by simply using the con parameter. And once we do that, we return now the result of that. And we're using PD, read SQL query, to be able to read from the data source. Let's run that. And transform. So once we have extracted our data and we've returned here, the data here, we will take that data using transform, and we'll merge the two data sets. And we'll return the merged pandas data frame. Transform data doesn't have to do a lot. So we have two components: extract, transform. That's part of our pipeline. Then we can load. So we can decide now again to create a, you can decide to set up a different destination source, maybe another Postgres database, and connect to it. We can connect to it just the way you have seen here. Sorry guys, I have forgotten. I'm sorry guys. Just to quickly recap what I was saying is that let me go back quickly. So I was saying that we can connect to our Postgres database using this particular code that we see here. This is the F string that provides a connection. But again, once we have connected to our data, we create an engine using the create engine, and that's what we get from this connect database, and that's what we actually call later to create and perform our queries on the database. And in the extract function, we use pd.read SQL query as shown here, .con engine, the same case here. All right, then we transform our data in this particular function. I think this is straightforward. So we'll get the merged data. Then in the destination source, we can create another database using, we're going to use Scicop G2 to create another database. This doesn't matter. You might create your database just once and that's it. Or you could decide to go this route, or you could also decide to create a database using some clients like Postgres clients, but doesn't matter. In many cases, you can use any that feels comfortable. So you create a new database, maybe, let me say DB6, destination 6. Created that database, so I connect to it. I'm still using Scicop G2. Connected, then actually here I've created a table, a destination table called merged data. Then I construct the pipeline. So here I'm going to use SQL Alchemy to connect to the database. So connect to database, I am using, which one am I using? Connect to database, destination. Okay, I can still use, okay, I see what's happening here. I can use this particular bit, I can use this, but I would want to use what I have here. So I can copy this so that I use that. I'll just paste it here so that I connect to this database. I don't refer to this database over here. Actually, that's what I'm doing. Was it what I'm doing? Oh yes, I connected to the new database. Sorry guys, actually connected to it here. I did not use Psychop G2. I used a different database. So wait a minute. So we need to create a database. We can just work with the database that we have here, destination DB. It will tell me that it has an error. Let me clear this. Create database, connect to database. I've connected to this database. Then I can decide not to. I just use SQL Alchemy for this. Sometimes there's always a confusion, but here we're using SQL Alchemy. And then once I've connected to SQL Alchemy, I can now load the data. I use a try except statement for just being able to capture the errors here. So what I'm doing is just I'm taking this data frame, merged df, which is what I get from the transform data, which will be the first parameter. And then I apply to SQL. So I want to insert data to an SQL table. I mentioned the table name and the destination engine. And if it exists, we are going to replace the entire table. We just want a clean table. Index, we want to exclude the index column. Normally that would be given. And the method here, multi, just means we insert our data quickly to the table. And we print out our results. And we can be able to execute the pipeline as shown. So we have customers, engine. So we have our engine here. So here we can have a source. This is a source. So I should have updated that. So this is a source engine. And we are extracting data from our source engine. And then we are merging data using the transform function. Then we load the data. And then we are merging the data. We are actually running this function load to this particular table name, customer information, which is what we have specified. Which is what we have specified that we want to create a table in that particular case. So here we just specified the column. So but you could also specify it here, but I don't think you need this. You don't need this. And then you can just simply verify your pipeline. So information, but it's still okay. You can say information. This is the table. So we are just verifying whether we had stored the data there. And we can now close the engines as shown here. So, but generally, apologies for those small mistakes, but generally what would happen is that you would have the code for what we have in assuming that you already have a Postgres database, you'd have this code in your pipeline, this code as well. In our .py file, you'd also have this code for extracting. So the code over here is just to connect to the data source. You just define it once and be able to reuse that engine. Then you are able to extract the data using this code, transform it using this code. Then you can be able to construct, not construct, but you can be able to execute, to load the data using the code that you have here. Normally, you might have two sets of these details, configuration details, if you have two data instances, Postgres instance. Maybe you have an instance where you're pulling data from and a different instance where you are sending data to. So I think that's it. If you would want to just review the code and see what happens. We had also done a data engineering with Python workshop earlier. You could always just go back to those challenges that we have provided in that workshop and see whether you can be able to implement those. that's it for this working experience. We hope you're able to learn a lot and you are able to get just an idea of what data engineering with Python and Postgres entails. Apologies for not giving challenges for this particular case. I'll make sure to give you more challenges for the next particular learning experience. And in terms of maybe going forward after this particular workshop, I would highly advise that you practice with just different cases. Like, look at how you can be able to maybe store data that you've collected from CSV in a Postgres database using just the concepts that we've showcased here. And also how you can optimize. There are many ways you can optimize and also ensure that your application or your data pipeline is secure. There are a few things that we haven't gone through, but that's what we would advise as next steps. If you liked this learning experience, be sure to give this video a thumbs up. Tells us that we should keep on continuing. And if you'd want to be informed when we post such future courses, be sure to subscribe, and see you in the next